Hello everyone, welcome to my channel Precision Manufacturing System. Today I'm going to present a new project which is related to powder simulation. Before doing anything, please subscribe my channel to increase my motivation to provide more project for you. Uh, Today, as I told you already, I'm going to explain how to prepare your own Python script for generating particle. In this Python script, I'm going to explain how to consider fine powder percent, coarse powder percent, and also how to define initial relative density for your RBE. As you know, for Python script, it's necessary for us to import some module. For example, in this Python script, I import random module, mass module, Abaqus module, and other module it's necessary for our project. Before doing anything, it's necessary to define intersection, intersect, and run for generating a particle, and also define intersection between two particles. Already in my previous video, I explained about intersection, intersect, but I also explain now. First of all, it's necessary for us to provide a definition of intersection between two particles. So we provide a function named intersection. R1 and R2 is related to radius of particle 1 and particle 2. Sen 1 and sen 2 is related to center of particle 1 and particle 2, and tolerance between particle 1 and particle 2. So first of all, it's necessary for us to define distance between two particles. Sen 1 0, sen 2 0 means x position. Sen 1 1, sen 2 1 is related to y position, and sen 1 2 and sen 2 2 is related to z position for particle 1 and particle 2. So we it's necessary for us to define this definition for the distance between two particles. It's necessary for us also provide a definition for mean distance between particle 1 and particle 2. So R1 plus R2 plus tolerance means the minimum distance between particle 1 and particle 2. If the distance is bigger than minimum distance, there is no intersection between particle 1 and particle 2. Else if the distance is lower than minimum distance, there is an intersection between two particles. After that, it's necessary for us to define a function named intersect to check is there any intersection between two particles or not. So when we import the particle 1, because there is no any particle, so the intersect is no, and R1 we did also define R1 for particle 1 means C1, 3 means the radius of particle 1. If for and sen 2 means that the another particle we import from the sent list. Sent list means there is lots of particle we generate for this project. So for SEN2, R2 is SEN2 3. So we check intersection between particle 1 and particle 2. If check equal yes, means there is intersect between particle 1 and particle 2. So when we encounter intersection between particle 1 and particle 2, so we eliminate particle 2 and try to import another particle. If there is no intersection between particle 1 and particle 3, so we import particle 3 and import another particle, and we check the intersection between the particle we import. For example, we import particle 1 and particle 2, so if there is no intersection, so particle 2 is okay, and we import particle 3 and we check the intersection between particle 1, 2 and 3. If there is no intersection, so it's possible for us to add particle 3 and other particle. And also it's necessary for us a function named ran to import to import particle with determine position, means x1 and x2. In this section, it's necessary for us to define some initial parameter. As I explain my previous video, it's necessary for us to define W com, H com or L com for our RVE size. In this project, I define WCOM, HCOM, LCOM 0.350 micrometer, and another one is necessary for us to define our maximum radius and minimum radius. In this project, I consider 0.083 micrometer as a maximum radius and 0.006 as a minimum radius. And also it's necessary for us to define median radius for fine and coarse particle, means average radius. So minimum radius plus maximum radius divided to to consider average radius. And also it's necessary for us to define tolerance for the minimum distance we consider here. I consider 0.0005 for our tolerance. And also it's necessary for us to consider initial volume fraction or initial relative density. For this project, I consider 0.225. It means it's possible for us to import particle in our RV with initial relative density, maximum initial my initial density for this project is 0.25. When for example, the summation of a fine and coarse particle is more than 0.25, it's not possible. It's not possible for us to add more particle. And In this section, also we define new parameters for error margin. For example, we consider error margin, for example, 1%. So we define 0.01. And volume fraction, initial relative density, target upper is I defined must be equal initial relative density, and for a lower initial relative density I define this function initial relative density multiply 1 minus error margin, and also it's as I already explained, we need to provide a definition for fine person and coarse person. So volume fraction for fine particle is 0.0 multiply initial relative density, and for coarse percentage is also equal 0.5 multiply initial relative density. And also we can consider error margin for upper and lower percentage for fine and coarse particle. You can see this definition for fine and coarse particle in here. So also it's necessary for us to consider initial volume fraction for fine. So the initial is 0 for fine and coarse, so it's necessary for us to define here. And this is the scent list, as I already explained. Scent list involve your particle you add in your RVE, and VFF means volume fraction for particle, fine and coarse particle, and it's necessary for us, or VFF for fine and coarse, summation of fine and coarse, it's necessary to equal or lower than 0.25. So initial VFF volume fraction for particle is 0. And also another one I consider in for in my Python script for generating powder is considered the fine particle count, means the counter of fine particle. Calculate the fine particle, for example, how many fine particle we add in our RV, and also coarse particle count. So the initial counter is 0 for fine and coarse, and it's necessary for us to define this definition here. And also I provide a definition for initialize the particle counter. Is necessary for my Python script. I will explain in the following. So in my Python script, I consider two sections for fine and coarse particle. First, I import determine coarse particle, and then import determine fine particle in my RV. First of all, I define if while my volume fraction for particle is lower than my initial relative density, that VF coarse upper we define here. And if while its volume fraction of particle is lower than initial relative density, we can add a new particle. So for every particle, we try up to 10,000 times to add a new particle. Another thing, as I already explained, the counter the maximum number of fine or coarse particle. In this section, I try to add coarse particles. So if the particle counter is bigger or equal 9, print maximum of 9 particle reach, so break the code. And so after break, it's not possible for us to add a new particle. This is a condition I define to control my maximum maximum powder coarse particle. So the new radius of the new particle is random between R minimum and R maximum. Generate a radius within the full range we consider in this section. Only add a particle if it is a coarse. So if a new radius is lower than average radius or R met we define here, is lower than R met, so we skip the program and try to add another particle as a coarse particle, because when we encounter in this condition means the new particle is fine particle, so it's not possible for us to import at this moment. And another one, we check if the target volume fraction for coarse particle is already met. For example, if the coarse particle volume fraction must be between volume fraction lower volume fraction for coarse particle and upper volume fraction for coarse particle. If we encounter this condition, we met this condition, keep adding more coarse particle if the target is met. Another thing is generate new coarse particle. So if we have we pass all of this condition, we can define new particle or new circle. I define here and define the position. For example, we import a new particle. It's necessary the new particle met the the new particle must be inside the RV with this definition. So if the new particle don't met this condition, so the new particle eliminate from the RV and we try to produce another one. And also check the intersect. I define already. If there is no any intersection, so it's possible for us to add new particle with this condition. So if there is no any condition, means check mean equal no. So in our sent list we add new particle and calculate the new volume of our new particle. This is the definition how to calculate the volume of a spherical new circle theory means the radius of our new spherical powder, and then and calculate the volume fraction of new particle. This common means volume fraction equal initial volume fraction plus new volume fraction for the new particle is necessary for us to calculate and add this comment to update our volume fraction for every new particle. And then this comment calculate increment coarse particle count. For example, we add one particle, so this is add two particles, this is 2, 3 is this is 3, and until we encounter this condition. When we encounter this condition, so it's not possible for us to add more coarse particle. So particle added through and encounter one and break exit the inner loop, and as the particle is successfully added. If not particle added, print this comment fail to add a new coarse particle. After 1000 attempts, try with a different particle and continue with the next iteration of the while loop. We consider here, we define a while loop here. And another condition, if the volume fraction for coarse particle is more than upper volume fraction for coarse particle, we define here, and we consider upper volume fraction for coarse particle must be 0.0 multiply initial relative density, or the particle counter is bigger or equal 9, so break our loop and continue another loop. So, and also I define this comment to print total volume fraction VFF and coarse volume fraction VF coarse. And another loop we need for fine powder is we define while loop, and if the volume fraction for VFF for fine loop is lower than the lower VF target, so we start a new loop, and first and also we defined a definition for trying a new particle. Try up to 1,000 times for each new particle to add a new particle in our RVE. For fine particle, I define a counter more than 780 if the particle counter is bigger or equal 780. Print maximum is maximum of 780 particle reach, so break our code. Break if the maximum number of particle is reached. and don't try to add more particle. And also this is the definition of new radius, generate a radius with the full range. This loop is also similar with the previous loop. And also if new radius is bigger or equal or average, skip the loop, because it means this is the coarse particle. If this definition is related to coarse particle, so this is fine. So in this loop I'm trying to add the fine particles. So the our new radius is bigger than our average, means this is a coarse particle, so we skip the loop. And another thing, check if the target volume fraction for fine for fine or coarse particle is for fine is already met, means if a fine particle volume fraction of fine particle must be lower volume fraction for fine and upper volume fraction for fine. If we met this condition, we skip adding more fine particle. And for generating a new particle, it's necessary our particle inside the RVE size. So with the definition we examine the particle is inside the RV or not. If the particle is inside the RVE, so we add the particle, and then also check the other condition. If not, our particle is not in the RV, so we eliminate the particle, and we don't check other condition and try to add or import another particle. So after that, we check the intersect between a new particle and previous particle. If check equal no, means it's possible for us to add new fine particle and calculate the new volume of the particle, and check the volume fraction of fine particle with this definition. And this comment consider the number of fine particle, and VFF means the summation of fine particle and coarse particle. If we encounter this section, so it's not possible. This definition is not possible for us to add more fine particle. And other thing is similar with the previous loop. And another thing, if not possible for us to add a new particle, we print this comment and try with the new particle, continue with the next iteration of the while loop. And finally we check if we encounter this condition, volume FFP defined here is bigger than upper target volume fraction target, or particle counter is bigger than 780, so break the loop, and it's not possible for us to add more fine particle. finally print the total volume fraction, VFF, fine volume fraction, VF volume fraction for fine and volume fraction for coarse. And also with this command we print the final RV, the dimension, total particle, add number of fine particle, number of coarse particle. With this command also we generate a cent list and export the cent list as a text file, and consider the x, y, z and r for every particle. With this comment we export the radius of a particle as a text file. You can see how to write this comment in here. And also we export our simulation data, result, total volume fraction, fine volume fraction, coarse volume fraction, final RV dimension, WCOM, HCOM, LCOM, total particle we added in our cent list, number of fine particle, number of coarse particle as a text file. You can see this command and how to define this command in your escape. And other thing I explained in my previous video about our RV die wall, creating punch and add die 1 1, die 1 2, die 1 3, die 1 5, 4 and 5, and also punch, and also how to define particle in our assembly module, and how to define property. I explain completely in my previous video. If you have any question, please send a message to me and I will answer your question as soon as possible. And also I define other section, material, mesh, module, intersection, and other module is necessary for us to perform a simulation. As I already explain in my previous video, you would be able, after watching my previous video, you would be able to do all the thing to generate your particle and perform your simulation. So at this time I try to use this script to generate my particle with the initial relative density, determine fine and coarse particle percentage. So I use this tab file tab and use a run script and OneDrive. Start new folder and random distribution. Okay, as you can see here, we try to add the particle, and also you can see here try to 1000 attempt to add a new particle with the condition we define in our script. As you can see here, when we add a new particle, we consider all of the things we define in our Python script. Okay. As you can see here, the number of coarse particle is 9, the number of fine particle is 771, and the total particle we added in R RV is 780, and W comp, H comp and L comp is 0.75. And also you can find the other information we provide in our script, Python script. For example, this is the center of particle 1, x, y, z, and radius. Another one second, the second one, third one, and other particle information. This is the R cent list. And this is the simulation result you can see in here. And at this moment we try to mesh the particle. You can see here, you can see the process for all particle, the number of elements for each particle. Okay, for example, this is the property of our material. Assembly, you can see the particle. So I remove the datum to see particle, and also remove the die 1, so die 5 remove, and also remove punch. Okay, this is the particle we generate: coarse particle, fine particle, and there is no any contact between two particles. You can see here. Okay, there is no any distance, you can see. And also I explain, this is our RVE datum, remove datum, and okay, you can see particle in here. Okay, this is the RV, and all of the particles are inside the RVE you can see here, and this is our step. Let's define. This is the intersection, so define intersection. Okay, for example this one. Okay, we define in our script. This is our load. This is the mesh. Okay, here and this one. Okay, remove the die and punch to see mesh. Move. Okay, you can see here this is the mesh. Finally we define a job. Okay, job 1, or for example compaction model 1, continue and okay, and then we submit. At the